In this video, we will talk about three learning objectives. First is to properly apply basic trigonometric identities and algebraic properties to express one trigonometric functions in terms of the other trigonometric functions. Second is write a proof which verifies the validity of a stated identity. Third, solve the values of trigonometric functions using identities. To achieve this objective, which is the first one, we need to have a good understanding of the fundamental trigonometric identities and algebraic properties. Trigonometric identities are equations that relate different trigonometric functions to each other. Some of the basic trigonometric identities include Pythagorean, Pythagorean identities. And we have reciprocal identities. We also have quotient identities, and co-function identities. Co-function identities. By using these identities and algebraic properties such as factoring and simplifying and manipulating equations, we can express one trigonometric function in terms of other. For example, you can express sine theta using the Pythagorean identity sin to the power of 2 theta plus cosine to the power of 2 theta is equal to 1. The next objective is to write a proof which verifies the validity of stated identity. Validity. So, for example, we have to prove the identity of tan theta is equal to sine theta divided by cosine theta. Starting with the right hand side, we have sine theta divided by cosine theta, and we'll use the definition of sine theta and cosine theta equals opposite adjacent, canceling out the common factor of hypotenuse. This is equal to tan 0 according to the definition of tangent, which is equal to tan theta is equal to opposite adjacent. Hence, the identity is proved. And lastly, the last learning objective, which is number 3, is solve the values of trigonometric functions using identities. This objective involves using trigonometric identities to find the values of trigonometric functions. By manipulating equations and applying identities, we can simplify expressions and solve for unknown variables. For example, if I have an equation involving sine theta and cosine theta, I can use the Pythagorean identity, sine to the power of 2 theta plus cosine to the power of 2 theta is equal to 1. To express one function in the terms of the other, this can be useful when you need to find the value of a trigonometric function given the value of another function or angle. For example, find the value of find the value of sine 45 degrees. Using the fact that sine 45 is the same as sine, this is the same as sine pi over 4. Due to the conversion between degrees and radians, we can solve it as follows. We can solve it as sine pi over 4 is equals to square root of 1/2. Here we use the Pythagorean identity sine. We use the sine squared pi over 4 plus cosine squared 2 pi over 4 equal to 1, which gives sine pi 4 is equals to cosine, we'll transpose this, sine is equal to, sine pi 4 is equals to cosine pi 4 and is equal to square root of 1/2. Therefore, sine 45 degree is equal to sine 45 degree is equal to square root of 1/2, which simplifies to 1 divided by 2 or 1 over 2 or square root of 2 over 2 in rationalized forms. These examples demonstrate how each learning objective can be applied. By practicing and understanding these concepts, you will become proficient in trigonometric and its various applications. That's all.